Keep it going. Hello.
Hello, here we have the demonstration for our integrated hospice care system. What we are going to do is we're going to show you a prototype, the infographic, and
the data we collected and how we analyze it.
we have
Min.
Habib,
Alex.
and lastly we
have
have
Lin. Hello, I'm Jingping, and this is the explanation for our integrated hospice care system. Firstly, we're going through our table of content, which includes the driving question, the problem, the sensors we use, the design implementation, and finally the codes and our flowcharts. So firstly, we were given a question: how can we design a sustainable technology solution in retail, urban farming, smart factory, or healthy lifestyle? We decided to formulate our own driving question. How might we design an integrated IoT system to improve hospice care? So, why did we think of this idea? Well, the problem is simple. The elderly are prone to falls, especially in private areas like toilets where the floor is commonly wet. Secondly, the elderly require a comfortable and healthy environment to live in. Lastly, the elderly are prone to illnesses at old ages. Now, I'll be passing my time on to Habib.
Our research into enhancing hospice care reveals that 80% of elderly falls occur in the bathroom, signaling an urgent need for improved safety measures. Furthermore, many elderly individuals are unable to recognize signs of illness and require the need of nurses to measure their vitals and temperature. We also have gathered from the general consensus of the patients that they would like an average temperature between 23 to 30 degrees Celsius and humidity levels between 40 to 60% to ensure that they are comfortable throughout the day. It is also been mentioned in regulations to make sure that the CO2 levels in the rooms of these patients are kept below 800 parts per million to ensure good air quality. Additionally, we also observed that the normal heart rate for the elderly ranges from 50 to 80 beats per minute, and that a healthy body temperature lies between 36.1 to 37.2 degrees Celsius. It is our introduction to our project. Our project's goal is to elevate hospice care by implementing a monitoring system that ensures the environment is safe and comfortable. This system will continuously monitor air quality and other safety parameters, alerting staff to any potential risks or incidents promptly. This enables immediate and effective interventions, safeguarding the well-being of our residents.
These are the sensors we will be using. In the Environment Monitoring Unit, we rely on the ENV2 sensor to track ambient conditions like room temperature and humidity, and the TVOC sensor to detect any potential harmful gases in the air. Our Health Monitoring Unit is equipped with a pulse oximeter to accurately measure the blood oxygen saturation and pulse rate of patients, complemented by the NTIR2 sensor for infrared temperature readings. The safety unit features an earth sensor for detecting floor wetness, an RFID sensor for identification and tracking, and a gesture sensor to allow for non-verbal commands or alerts within the toilet facilities to indicate accidents. These are the block diagrams, which are the blueprint of our system's architecture and will be shown alongside our demo video. For our design implementation, we start with the Environment Monitoring Unit. Here, the ENV2 and TVOC sensors play a vital role in maintaining optimal room conditions by monitoring temperature, humidity, and air quality. The collected data is then utilized to adjust environmental controls, creating a comfortable and safe space for patients. Moving to the Health Monitoring Unit, the pulse oximeter and NTIR2 sensors aid in assessing vital health parameters. These sensors are essential for real-time health monitoring, providing data that can be used to detect early signs of health issues and adjust care accordingly. Lastly, the safety unit sensors are particularly focused on fall detection and patient safety in the toilet area. They alert staff in real time if a patient falls, ensuring immediate assistance and monitor the presence to maintain patient privacy and aid as necessary. These are our flowchart maps. Stay tuned for our demo video. We will be explaining these flowcharts in depth, ensuring a comprehensive understanding of how our system proactively manages patient monitoring and safety.
Here is our first unit. It has an ENV2 sensor and TVOC sensor to monitor the humidity, room temperature, and air quality for the elderly.
if any of these sensor data goes off the limit which is shown below, the LED bar will turn red and the picture color will change. Let me demonstrate this using the temperature, which is currently 24 and the lower limit is 23. Allow me to increase the lower limit. Press. Oh, my bad. Oh, I skipped it. I'll go back. Pressed. Okay. So I will increase the lower limit to be 25. And then the LED bulb will turn red and the picture is showing that it's very cool, so the AC will turn on to warm down the room. Let me toggle it back to go back to normal. Okay, it's normal now. And the TVOC sensor and the ventilation, if the TVOC amount goes up to 220, the ventilation will open and the window will open also. Can you test? Okay, so we're 400. And then it turned red and the window is opened. And then the current TVOC value is still going down, 765. Let's wait, if it goes below 220, the ventilation will close back and the window will close also. There, that's how the first unit works. This is our second fire unit, which includes an NCIR2 sensor to monitor the body temperature and a heart rate sensor to monitor the patient's heart rate and SpO2.
Okay, so we also have an angle unit which allows us to control the angle of the bed. This way, the patient is able to put the bed into an upright position or in a lying down position so that they are able to be comfortable at all periods of the day. We also have a heart rate sensor and an NCIR2 sensor. What these do is measure the blood oxygen and the heart rate and the person's body temperature. So to make sure we start them off, we must press the A button to start measuring. This will turn on the heart sensor and will also allow us to take readings from the body temperature sensor. So we now have Jim Min allow us to use him as a test subject. Please put your finger onto the yes, and then we shall put the heart rate sensor onto his wrist. We can now see that he is actually very cold and he is probably sick. So we can see that the images change according to what the readings are given. Since he is very cold, his fingers are very cold due to the temperature of the room, we can see that he has a temperature reading of 12 and it has changed into a cold image. So if he was above 37, it would change into an image of a sick person, indicating that he is sick or infected. And it's the same for the other two images.
So this is our third unit, which include a gesture sensors to detect accidental falls in toilets and an arch sensor to detect the floor wetness. So Alex?
If you start from outside, you will see that there's an RGB indicator at the top. When it indicates green, that means the toilet is available for use. To enter, you just need to scan an RFID card. This will turn the RGB sensor red, indicating that the toilet is not occupied. You can enter the toilet through this door. Once you enter the toilet, you can press the lock button to lock the door and use the toilet as per normal. In the occasion where there is a fall, indicated by a downward movement, you will see that there is a 5-second counter. If you don't press the button within timing, it will start to beep. The beeping will also be reflected on the RGB sensor on the outside, which will show that there is an accident occurring inside the toilet. In order to stop the beeping, we need to scan an RFID again, so that it will indicate that help has come. The door will automatically unlock, and then help can access the person that has been injured. During the countdown, if you press the button in the middle in time, the countdown will stop, and everything will go back to normal.
Okay.
In conclusion, we have an integrated hospice care system using these 3 and 5 steps. The first one being an environment monitoring unit, the second one being a health monitoring unit, and the last one being a safety monitoring unit for the toilet. Lastly, all these 3 and 5 stacks will automatically upload itself to the cloud every few seconds. All this data can then be formatted into different types of graphs for easy viewing. Thank you.
We hope you enjoyed our project demo video. This is part of our blocky code, and for more information and resources, please scan the QR code on the screen for the Google Drive link. Through our versatile project, we aim to solve 3 of UN's SDG goals, which are promoting good health and well-being, especially in remote hospices, providing a resilient infrastructure by having an optimal working conditions in offices, and building smart cities by reducing electricity costs by turning off air conditioners and air purifiers when they are not needed, and reducing human resources by automating some of the repeated tasks. That is all we wish to present. Thank you for your time and attention, and we hope to see you again in another IoT project video.